Thankfully, we are done with exponent properties. The remaining 2 lessons involve graphing square roots and cube root functions, transforming them, and then solving square root and cube root equations. Okay? We are going to be graphing the parent function for a square root y equals root x. If you have a calculator, please graph y equals root x. And y equals the cube root of x. We know that we can write this as y equals x to the 1/2, and we can write this as x to the 1/3. Let's start with the square root of x. This is called a radical function. A radical function contains a radical expression. I mean, it's like that. Okay, so y equals, I don't need 0 right now, so I'm getting 0 out of there. I can either write x to the 1/2, it's all off, or you can write the square root of x, right? Square root, crap. This is what the square root of x looks like. Why does it only start at 0, and why isn't there any graph on the left? Let's plot some points. Let's just start. Let's graph first, and then we'll talk about it more. I can use my table. You guys know about trace, right? I got the point 42. Why do I have the point 42 on the graph of the square root of x? Let's plot that point. 4, 2. I'll give you another point. 9, 3. Why is the point 4, 2 and 9, 3 on the graph of the square root of x? This is very important. Like, why are graphs created? Where does a graph come from? Where does the point 4, 2 come from? 0. I mean, 0, 0 is a point. That's a good observation. Yep, 0, 0 is a point. 4, 2 a point. 9, 3 is a point. Where does the graph, where does the shape come from? Where does the shape come from? It's not a line. It's not a x squared. What? Slope? Nice. You're thinking like calculus. But no. Where do the points come from? Where's the graph come from? Your calculator? How does your calculator know what to do? No, it's like a curve. It's like a curve. It's not a straight line. It's a curve.
X squared used to be a curve.
Yeah, x squared was a curve too. Okay, so square root of x is a curve. Where do the points come from? I'm asking you, where does the point 2, 4 come from? Why do I know 2, 4 is a point on this graph?
Multiply it by 2.
Because of the half? 3 times 2.
The square root of the x value 4 is 2. This is important. Where do points on graphs come from? It comes from the ordered pair that works in the equation. 4, 2. Plug in 4, you get 2, right? What would be the y-coordinate going with 5? I don't know. Whatever the square root of 5 is. 2.2360069. That's why we have the point 42, why we have the point 93, because the square root of 9 is 3. It's all the points that work in the equation. It creates the shape. Why does an x squared graph create a u? Because all of the points that work end up creating a u. 2, 4, 3, 9. Well, now we have 9, 3, and 4, 2. Okay? It is a curve, and it doesn't exist over here. Why not? Why? That's it, Miss Abernathy. Because if I asked you, hey, what's the point when x is -4? You'd be like, well, it'd be the square root of -4. That would be the y-coordinate. But that's imaginary. And guess what? Your calculator doesn't deal with imaginary numbers. You guys know about imaginary numbers. Calculator doesn't. Okay? So this is why there's no graph over here, because the square roots of negative numbers are imaginary. This is not an imaginary graph. These are all real numbers here. Does this make sense to you guys? Why there's no graph over here and we're just starting at 0, 0? Now, what's the domain of this graph? All real numbers is what we want to say every single time. Now, remember, domain is our x's. What are the x's that we can use that we see the graph of? 0 to infinity, including 0, or x's bigger than or equal to 0. What's the range? It's not all of the y's. We wish it was all the y's. Nope. All the y's starting at 0 going into infinity. That's all my y's bigger than or equal to 0. Why are there no values down here? It's a good statement, good try, but that's not what I'm looking for. Why are there no numbers down there? Because the square root of a number is always going to be a positive. The square root of 9 is just 3. The square root of 4 is just 2. The square root of a positive number can only equal a positive number. All right, let's look at y equals the cubed root of x. Who could give me a couple points without graphing on the cubed root of x?
3, 6.
3, 6, nope, doesn't work.
2, 8.
2 and 8 doesn't work.
3 and 9.
3 and 9 doesn't work. 2 and 6 doesn't work. 8 and 2 works.
I just said that.
You said 2 and 8. 2, 8 doesn't work. 8, 2 works.
I didn't know the order matters.
Of course the order matters. It's x first, then y, right? Right? It's x and y. 8, the cubed root of 8 is 2. Boom, you got that point. Good job, Miss Abernathy. You're picking this stuff up. What would be another point that you would know? Who said 27 earlier? 27, 3. Where's 27? All the way over here. Can you even graph it? Nope. 1, 1 works. 0, 0 works. Are there going to be negatives here?
No.
No. Is 0, 0 point?
0, 0 is the point. The cube root is 0, 0.
Yeah.
Are you sure?
Just keep thinking it's smaller fraction, but never cross.
What's the cubed root of negative 8? It is negative 2. Because negative 2 times negative 2 times negative 2 is negative 8. So we actually do have the point negative 8, negative 2. Go ahead, graph it now. You'll see it. It's very similar to the shape of these square roots, but a little bit different in that it goes to negatives and positives. Why? Because you can take the cubed root of a negative. It's a negative. It's not imaginary. And that's why you see values over here and down here. The domain now is all reals. The range now is all reals. Now, it doesn't look like it. It doesn't look like we're using all the y's. But we're just going to have to plug in larger and larger values of x. I'm going to have to plug in 1,000 to get a y value of 10. I'm going to have to plug in 2,700 to get a y value of 30. Okay? The larger and larger values you plug in, you're going to get larger and larger y's. But now we're starting to think about plugging in values getting close to infinity. So it doesn't look like it's going to go all the way up to infinity, but it does. Okay? Now, we need to remember transformations. We've done transformations all year. We have a function, we got stuff inside, and we got stuff outside. When you change stuff inside a function, what does it affect? The x's or the y's? inside x's. When we subtract 3, do you think we're going to subtract our x's by 3 and shift to the left? No, because inside ends up happening opposite of what we're used to. Remember this? Remember, outside was my y's, and it's normal. Now, for these, you're going to be able to graph in your calculator, right? And you'll be able to see what type of transformation, Ms. Crabtree, since you're already working your way out the door. If I have root x minus 3 plus 2, where are we shifting and how are we shifting? Okay. It's up 2, and it's to the right 3 is exactly right. You will be able to get that by graphing. Okay? That's easy. What you won't be able to get by graphing are these questions, where it's like, hey, stretch this, translate this. Hold on, I'm not done. I know, and guess what? The bell hasn't rung yet. If you are vertically stretching, that's the y's. You're not shifting, you're multiplying. If you're going 2 to the right, you'd be subtracting inside. This is my new function g. Let's do another one, because we have plenty of time. Plenty of time. I got the square root of x function. I will stand at the door and wait until you guys write down the answer to this question. So, Ms. Reyes, you're already packed up. I got f of x equals the square root of x. I want this to go 4 units down. What would I write? 4 units down? On the outside? Minus 4, good. But I'm reflecting this across the x-axis. Negative x inside or outside? Look at you, Ms. Crabtree, saving the day for your fellow teammates. We will do the rest of the notes that we don't get to at the beginning of next class. Enjoy. Oh, if anybody leaves a calculator on their desk, I'm going to be pissed.